Figure below shows the position time graph of a particle of mass 4 kg. Okay. What is the force on the particle from for the time less than 0? So t less than 0 is over here. T greater than 4 is over here. And t between 0 to 4, not including 0 to 4, is this line. Then we have to figure out the impulse considering one-dimensional motion. Okay. Now we have case by case. We can go with it. So we have A. So for time less than 0, what do we have? We have no movement. No movement means, so we have to figure out the force. No force. So the object is at rest over here. Honestly, it is at rest over here. Here too it's at rest. Here it is at constant velocity. So what is that I'm trying to indicate? There's nothing much happening actually. For, oh sorry, it's the same question. For t greater than 4 second, what is happening over here? The object is at rest again, so no movement. And so no force. Then for t between 0 to 4, 0 to 4 second. So here too, there is no force, but even though there is movement, the velocity is constant, means no force. Right? And then what do we have? Then we have impulse for t is equal to 0. Okay, let me discuss this now. So you guys, I hope you guys understood that this and this part is at rest and this part is with constant velocity. In all of these cases, there is no force. Then how is that object which was moving, started moving and then came to a rest? Because something happened at 0 and something happened at 4. So there was some kind of force that acted upon the object at this 2 point of time, only because of which it moved or changed its state of motion. That would be a better term. So there is change in state of motion at 0 and 4, and that is because of some force, and that's what we are trying to figure out. We're expressing in terms of impulse. So that's how we can think about, oh, there is some impulse, so there is some force. So we're just looking at impulse. So impulse is given by mass times of change in velocity. So mass times of change in velocity involves, okay, yeah. So we have to take case by case. At t is equal to 0 second. We have J is equal to, mass is how much, guys? 4 kg. And change in velocity is from 0 to, oh sorry, from, right? But yeah, we don't have the velocity over here. Final velocity is given by slope of this line. Slope of this line is 3 by 4. So 3 by 4 minus 0. This I calculated with the help of slope of what? OA. This is 0 also and this is O also. OA. That is the velocity, new velocity, and this will be 3 kg meter per second. That's the impulse at t is equal to 0 second. Now we are at 4th second. So J is equal to 4 times of, again, it was moving with 3 by 4th of 3 by 4 meter per second, but it came to a stop, right? It came to a rest. The displacement is 0. Remember, this is distance displacement time graph. This is not velocity time graph. So this also represent a rest at a displacement of 3 meters. And in this case, we are looking at minus 3 kg meter per second, indicating that the force acted in the direction of, or opposite to the direction of the movement. The impulse is opposite to the direction of motion. Okay, that's that. So you can pause and have a look.